All right, guys, today we're solving quadratics by factoring. We're going to factor, and we're going to use something called the zero product property, which we'll talk about in a second down here. Okay, for quadratics, where we have all three terms, which means ax squared plus bx plus c, set equal to 0, factoring and using ZPP, the zero product property, is the fastest method for solving quadratics. Okay, so we'll learn how to do this. Of course, it's the fastest. We don't want to use like quadratic formula every time. That's a giant waste of our time, especially on timed tests. Okay, so zero product property, what is that? It says for any two numbers, a and b, if a times b equals 0. So if you think about that for a second, if I have two numbers, a and b, and I multiply them together and our answer is 0, what's the only way that's possible? The only way to get 0 when you're multiplying is one of those numbers has to equal 0. So we can say either a equals 0 or b equals 0. It could be one, it could be the other, it could be both, but one of them has to be 0. And that helps us actually solve polynomials and quadratics very quickly when we get them into factored form. Okay, so here's some steps that we can use. The first thing we need to do to use zero product property is we have to have this condition that our factors equal 0. So the first thing we need to do is make sure my equation equals 0. Okay, we also want our x squared term, or that highest degree term, to be positive. So make sure it's on the correct side of the equation, or that you make it positive on that side of the equation by maybe multiplying by -1 or something like that. Then we want to look for any greatest common factors, or GCFs, to take out. Anytime you are asked to factor, the greatest common factor should be one of the first things you look for, okay, when we start the factoring process. That's really important. Okay, when a, that's the term in front of our quadratic, so we're talking about this variable a here. When a in the ax term is +1, we want to look for factors of c, which is the constant at the end, and factors are things that multiply to it. So two numbers that multiply to c that add up to b. Okay, so we're looking for values that multiply to c that add up to b. Then we're going to factor and use the zero product property to find our zeros, roots, or x-intercepts. Those are all synonyms. They all mean the same thing. All right, let's try some examples. Solve each quadratic by factoring and using the zero product property. Okay, so I can see first that my equation is set equal to 0, so that's good. We've met our first condition. Then I want to look for any greatest common factors. Okay, and nope, there's no common factor I could take out of all terms. Next, when a in the first term is +1, so in front of x squared is +1, which it is, we want to find factors of c, so factors of 14, that add up to b, that add up to -9. Okay, so you guys might remember doing this in Algebra 1. We go to factor here, we'll set our factors equal to 0. And to get to x squared, they're each going to start x and x. And we want to find two numbers that multiply to +14 that add up to -9. Okay, some of you guys might have seen this as x factor. In fact, I had like a little game that I can link for you guys to play. We want two numbers to multiply to +14 but add up to -9. So if you're stuck on those, you can always make a factor pair list. So 1 and 14, whoops, or 2 and 7. 3 doesn't go in there, 4, 5, and 6 don't go in there. And 7 would be a repeat. Okay, well, to multiply to 14, both of these pairs multiply to 14. But remember, to get to +14, they could either both be positive or both be negative. And in this case, to add up to -9, they have to both be negative. So in this case, the two factors we're looking for that multiply to +14 and add up to -9 are -2 and -7. So that's what our factors are, x minus 2 and x minus 7. The order doesn't really matter, so I didn't need to change that. Okay, but these are our factors, and factors mean if I were to multiply them back together, we should get back to the original here if we FOILed them together. Okay, but what we're doing, we're factoring this so we can use that zero product property. Remember, back here it says if we multiply two things together and their product is 0, and right now we have these two quantities multiplied together and their product is 0, then either the first factor or the second factor or any of the factors have to equal 0. At least one of them has to equal 0. So our zero product property allows me to set each factor equaling 0. So we can say either x minus 2 equals 0 or x minus 7 equals 0. And if we solve each of those by, say, adding 2 over or adding 7 over, we get positive 2 and positive 7. So when we're solving quadratics, you should always get two solutions. And here our solutions are positive 2 and positive 7. So I might need to save myself some space here. I wrote a little big. I will fix that and be right back. Okay, hopefully we can fit the rest of these in here. All right, let's try our next one. The first thing I notice is this is not set equal to 0. So we do not have our condition to use zero product property yet. So the first thing I need to do is set it equal to 0. And to make my factoring life easier, I want x squared positive. So since x squared is positive on the left side of my equation, let's move everything to the left. So move that 28 over, and we will have x squared plus 12x minus 28 equals 0. Now there's nothing on the right side of my equation. Okay, so now we're going to go factor again. I need to find the two numbers that multiply to negative 28 but add up to positive 12. Okay, so think about that for a second. See if you can come up with those two numbers. They multiply to negative 28 and add up to positive 12. All right, you should have come up with x minus 2, negative 2, and positive 14, so x plus 14. So those are our two factors. And again, our zero product property says if these two things multiplied together equals 0, then either x minus 2 equals 0 or x plus 14 equals 0, but one of them has to equal 0. So if I set each equal to 0, I get x equals positive 2 or x equals negative 14. So our two solutions, the two values that make that original equation true back up here, are positive 2 and negative 14. Okay, example 3. First thing again, I notice it's not set equal to 0, so we need to set this equal to 0, and my x squared term is not positive. So I want to move everything to the side that makes that positive. So I could move everything to the right. In fact, let's go ahead and do that option. So add x squared over, and let's add 30 to the other side as well. Okay, so now the left side is equal to 0, which is fine. Equals positive x squared plus 11x plus 30. So we put it in kind of that descending by degree form called standard form. Now we need to find our factors that multiply to 30 and add up to 11. So see if you can come up with those, because that's an important part of factoring. Multiply to positive 30, but add up to positive 11. See if you can find those two numbers. So pause now, try them out. All right, we should have come up with x plus 5 and x plus 6. So if we set each of those factors equal to 0, we should get solutions. X equals negative 5 or x equals negative 6. All right, one more example in this section. Once again, this is not set equal to 0. So let's go ahead and subtract our x to the other side. So we have x squared minus x equals 0. Now here again, remember the first thing we're always looking for, and I did kind of skip over that a little bit in our previous examples, is the greatest common factor. And here, this problem, even though it has that middle term in there, if there's no constant, right, our constant would technically be 0 here, you can actually factor out x as a common factor from our two terms. And if I divide an x out of both, we're left with x minus 1. And those two factors can be set equal to 0, either x equals 0, I'll use red, either x equals 0, or x plus 1 equals 0. Oops, sorry, x minus 1. Which means our two solutions are x equals 0 or positive 1. So this is not a coordinate point, this is just a list of values for our solutions, 0, comma, positive 1. Okay, here are a few more examples for you to try. This would be a good time to pause the video, try some of these out, and when you unpause, all of the answers will be here. So pause the video now. All right, here are your three answers. 2 and 1 for example 5, 8 and negative 3 for example 6, positive 4 twice at example 7. Okay, we have another example to do in this section. We've got some new stuff to add in. Okay, what about if I'm given something like this, where once again, if we look for our greatest common factor, you can probably find your answer very quickly. So pause, try this one out, see if you can get this. All right, there is our answer. Hopefully you came up with that. 0 and 2. Taking out d as a common factor. When you divide that out, it leaves you with d minus 2. And setting each equal to 0, we get 0 and 2. Okay, there's another important factoring method that we can use when we're solving by factoring. And it's a very common pattern. You will see this pattern all year, this year, next year, calculus. You're going to see it over and over and over again. It pops up all the time. So please make sure that you learn it now. It's a pretty easy pattern once you learn it. It's called the difference of squares. Difference meaning subtraction, and squares because we have two values that are times themselves twice, perfect squares. Okay, so if we have two things that are perfect squares and there's subtraction between them, they will always factor in this pattern. A plus b times the quantity a minus b. Okay, we just need to figure out what a and b are to put into our value there. Okay, so our first example here, we want to figure out what gives us a squared minus b squared. What are our values of a and b? It does have two terms that fit like these do too. Okay, so a very important pattern for us is something called the difference of squares. This pattern is going to pop up all over the place for the rest of the year. This chapter, next chapter, tons of future chapters. You'll see it in pre-calc and calculus. It's really important to learn. It's a very easy pattern, but you are expected to learn it. So try to learn it now. Okay, it says if we have two values that are squared, a and b, so perfect squares, and there is subtraction between them, hence the name difference of squares. If that is true, we have a factorable pattern that factors as a plus b times a minus b, where a and b are the values that are squared to make each term. So as we look at example 9, the first thing I notice, there is no greatest common factor, but it has two terms similar to our difference of squares, and there's subtraction between them. So I want to look at x squared and 49 and determine if they're both perfect squares, which they are. Okay, to find the values that we're going to plug in here for a and b in our formula, we need to figure out what value is being squared to create each of these. And to get x squared, you need to do x times itself twice. To get 49, we would need to take 7 times itself twice. So our pattern here factors out as a plus b, x plus 7, times a minus b, x minus 7. And these are our factors using the difference of squares pattern. And like before, if we set each factor equal to 0, we should get negative 7 from our first factor and positive 7 from the second. Okay, try example 10. See if you can come up with the correct factors. You could solve either of these with square roots. Technically, that is faster, but let's practice the difference of squares for now, because there are times where we want to factor and not solve, so square roots won't help us. So try 10, pause the video. All right, you should have come up with positive 5 and negative 5. The factors were x plus 5 and x minus 5, and our values of a and b were x and 5. Okay, this also applies for examples like 11. Okay, so for example 11, again, I see there's no greatest common factor, so it's the first thing to check for. But I do have two things that could be considered perfect squares. I know 81 is 9 times 9, and both the numbers 4 and x squared are perfect squares. because there's subtraction between them, I think we can use our difference of squares pattern. So slightly more complicated this time to find a and b. We need to figure out what times itself twice gets me 4x squared. And in this case, I need 2 squared to get to 4, and an x times itself twice to make x squared. 2x times 2x would make 4x squared. And the two numbers that multiplied, or the number times itself twice that gets us 81 is, of course, 9. So 2x is what we're going to plug in for a, and 9 for b. So a plus b, 2x plus 9, and a minus b, 2x minus 9. When we set each of these equal to 0, you'll have a couple steps you'll need to do to finish solving them. So for instance, 2x plus 9 equals 0. You need to subtract 9 and then divide by 2. So we should end up with negative 9/2 as one of our solutions. And when you do that with minus 9, our other factor, and you add 9 to the other side and divide by 2, we should get 9/2, positive 9/2. So our two solutions for 11 are negative 9/2 and positive 9/2. You could have gotten the same answer by solving with square roots. When we're solving, that's true. But again, there are going to be some times where I want to factor, and being able to find these factors with difference of squares is important. Okay, number 12, we're going to do together. I threw in a little extra hitch here. We finally have a greatest common factor. That's the reason we look for this all the time. And if I take out my greatest common factor of 3 by dividing both of those terms by 3, we're left with x squared minus 4, which is a difference of squares. So following our pattern from before, here my a value should be x, and my b value should be 2. So these will factor as x plus 2 times x minus 2. Now when we do the zero product property, you could be confused here by that 3 on the outside. We have 3 things being multiplied. And zero product property can actually apply to 36 things being multiplied. Each of those 36 things could be 0. So here we're saying either 3 equals 0, which it doesn't, or x plus 2 equals 0, which gives us a solution of negative 2, or x minus 2 equals 0, which gives us a solution of positive 2. So in this case, 3, not being a variable, not having x with it, just doesn't give us an extra solution. 3 obviously can't be 0. It's 3. So we only get 2 solutions here because we only had 2 different places with x. Okay, so now we're going to talk about how to factor when you have a value in front of x squared that is not positive 1. Okay, so first thing we do, of course, we want to set our equation equal to 0 to keep, so we can use the zero product property. And we want to keep a positive because that makes factoring easier if it's factorable. Okay, well, first thing, of course, factor out a greatest common factor. So here's an example where we can see, hopefully, that here these are all even numbers, so we could at least take a 2 out of all of them. And if you do so, we're left with 4x squared plus 7x minus 2. So even after taking out a greatest common factor, we still have a value that's not 1 in front, which makes factoring our quadratic a little more difficult. Okay, that actually gives us 2 different possible cases. Think about if I were foiling my factors back together and multiplying them back together, how could I get to 4x squared? It no longer can be just x and x for my factors. We need to have numbers in front of them. So we can see our 2 possible cases down below. It could be 2x times 2x, or it could be 4x times x. So a little bit of intuition, it's got to be one of these 2 answers. And obviously we still need to find the numbers plus or minus that fit in here. Okay, so just like we did before, but now with a little guessing and checking in these 2 methods, we want to find the factors of c, so in this case the factors of negative 2, that will give us a middle term of positive 7. So if you had learned FOIL with the first, outer, inner, last, we're kind of going to need to check which case gives me the correct oi part of FOIL, the outer and inner, which results in the middle term bx. Okay, so for instance, for this, I don't know if is it negative 2 and positive 1, or is it positive 2 and negative 1? which case would give me 7x if that's even possible with this case. Or maybe it's positive 2, negative 1 here, or negative 2, positive 1 here. So see if you can figure out which case, if you did the outer and inner, would give us the correct middle term, 7x. So pause now and see if you can figure out which one of these cases and where the 2 and 1 go, and which one's positive, which one's negative. All right, if this is the answer you came up with, hats off to you. Yes, our outer two terms here would give us positive 8x. Our inner two would give us negative 1, resulting in a positive 7x. So these would be our two factors from the quadratic, and we'd still have a 2 on the outside. And if I set all of them equal to 0, our solutions, obviously 2 can't equal 0, but from 4x minus 1, we'd get an answer of positive 1/4. And from x plus 2, we'd get an answer of negative 2. So our two solutions would be negative 2 or positive 1/4. Okay, let's move down here and try example 13. So first thing I look for, any greatest common factor, and there is not one. Okay, no greatest common factor. Okay, but this is set equal to 0 for us. So a little intuition, again, to get to 2x squared, if this is factorable, I know my factors are going to have to start 2x and x. Now, I know that my two numbers that we're going to either put plus or minus over here need to multiply to positive 2. So to multiply to positive 2, we can either have negative 1 times negative 2 or positive 1 times positive 2. Those are our only two cases, but I'm not sure which goes where. So we need to try to do a little bit of intuition on how to get to negative 5x. So keep in mind that whatever I put here, when we get our middle term, think of the oi part, the outer and inner, will be multiplied by 2x, and whatever I put here would be multiplied by 1x. And I need my result to be negative 5x, and we've got two choices over here. So figure out where those go. Try that out as a mental exercise. See if you can get the answer. I will put them up in 1 second. Pause the video. All right, if you came up with this, 2x minus 1 and x minus 2, I also noticed I forgot to write my equals 0, then you did a pretty good job. And if we set each of these factors equal to 0, here we're going to get 2x equals positive 1, and dividing by 2, we get x equals 1/2. Here, when I set x minus 2 equal to 0, we get x equals 2. Our two possible solutions are positive 2 and positive 1/2. Okay, let's go up to 14 up at the top here. This time it's not set equal to 0, so let's first move this 5x squared over. Okay, so we've added 5x squared to the other side. So now I can look for any greatest common factor. There is no greatest common factor this time. So again, with a little intuition, I know to get to 5x squared, luckily there's only one case. We won't have to cycle through a bunch of cases like we did in the example way back here. So it's got to be 5x and x, and luckily again, the number that needs to go next to them only multiplies to positive 2. So the numbers that multiply to positive 2 could be positive 1 and positive 2, or negative 1 and negative 2. To add up to positive 11, though, hopefully you have a little intuition in which case that probably is. So see if you can figure out where to put the 1, where to put the 2, and if they're both positive or both negative. So that, remember, my outer terms and my inner two terms, when we multiply them, should add up to 11x. So try that now. Pause the video. Okay, if you came up with 5x plus 1 and x plus 2, great job. This would give you positive 10x, and the inner two would give you another 1x, giving us a total of 11 x's. So setting each factor equal to 0, subtracting 1 over, 5x equals negative 1, and dividing by 5, x equals negative 1/5. From our second factor, x plus 2, when that equals 0, subtracting 2 over x equals negative 2. So our two possible solutions are negative 1/5 or negative 2. Okay, try 15 out. This one is going to be, I'm going to help you set up the cases, I guess, first. Let's first put everything on the side that makes x squared positive and set our equation equal to 0. Okay, next, I check for greatest common factor. There is none. So now we need to figure out how do I get to 6x squared. Well, now, like our original example, it could be 6x and x, or it could be 2x and 3x. Right? The order you write them in doesn't matter. So the 3x and 2x is the same thing. So we have to figure out which one of these cases where my numbers that multiply to -2, and I fit them in here, 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 or here, would give us that correct middle term of -1. So it's a little guess and check. See if you can find them. Pause the video now. All right, if you found out this was the correct solution, 2x times -2 would give us a -4x. Okay, and then 1 times 3x would give us a positive 3x. So -4x, positive 3x gave us the correct -1x in the middle. If you set each factor equal to 0, we get 2x equals -1, or x equals -1/2. Adding 2 over here, we set this factor equal to 0, we get 3x equals 2, and dividing by 3, we get 2/3.